The question here is a cube of metal 6 centimeter of 6 centimeter edge. A cube of metal of 6 centimeter edge is melted and cast into a cuboid whose base is 9 centimeter by 8 centimeter. Find the height of the cuboid. So what you have here is a cube, say this kind of a small cube, a bigger cube in fact. So you have this kind of a cube which is melted to form a cuboid. This is melted to form this kind of a cuboid. And what are the measurements given? It is given to you here that this cube is of side 6 centimeters. So all this is 6 centimeters. 6 centimeters, 6 centimeters, 6 centimeters. Okay, so all the sides of this cube are 6 centimeters. Now this cube is melted and a cuboid is formed. Okay, and what are the measurements of this cuboid? It is given that the base of the cuboid is 9 by 8 centimeter. So base of this cuboid is, so this length is given to be 9 centimeter and this length is given to be base. These two are the bases of the cuboid. These two lengths form the base, 9 centimeter by 8 centimeter. The question is, what should be the height of this cuboid? What is the height? What is the height of this cuboid? That is the question. Now see, if I melt this cube, and I'm forming a cuboid, and after melting, I'll get certain material, right? Whatever the cube is made of. Suppose the cube is made of tin. So I'm melting that cuboidal tin, okay, and I'm getting melted tin. And out of that melted tin, I'm making a cuboid. Am I wasting any material? Am I wasting any tin? I'm not wasting any tin. Okay. All the tin that I have got after melting, I'm utilizing it to make the cuboid. That means the volume of the melted tin must be equal to the volume of the cuboid that I'm forming. And what is the volume of the melted tin? The volume of the melted tin must be equal to the volume of the cube because I have melted the cube to form the melted tin. And from the melted tin, I'm making a cuboid. So I say let the height of the let the height of the cuboid formed be h. So that means this height I've taken as h. This height. Okay. So first we'll calculate the volume of the cube. Therefore, volume of the cube must be equal to 6 cube because each side of a cube is 6 cube centimeter cube. Keep it as it is. Okay. And what should be the volume of the cuboid? Volume of the cuboid so formed. Volume of the cuboid so formed. This must be equal to length into breadth into height. This much centimeter cube. Now this much material I am getting. Volume of the cube I am getting. This much material I am getting after melting. This material I am utilizing to make this cuboid. So the volume must be equal. So according to a problem, volume of the cuboid 6 cube must be equal to volume of the cube in fact must be equal to volume of the cuboid, and from here we can find out the height. Okay, now we can simplify this. This cancels with 3, this cancels with 4, this cancels with 2, and this cancels with 3. Okay, and any further cancellation? Yes, this will also cancel. 3 1, 3 2, and then this will cancel with 2, and these two will cancel. So it's only 3 that you are left with. The height of this cuboid is 3 centimeters. That's it. Let us see the next problem. But before going to the next problem, I'm going to give you two more formulas. I've given you the formula for the cuboid. Okay. Two more formulas are required in order to proceed further. And these two formulas are general formulas for any cube or cuboid, or in fact cylinders also. This formula applies to cylinders also. What is the formula? In fact, any solid that has a uniform cross section. Now, what do you mean by uniform cross section? Suppose in case of a cylinder, the cylinder has a uniform cross section. See, if you look at the cylinder from here, if you look at the cylinder from here, the cross section is circular. You'll see a circle here, right? Now, if you also cut the cylinder here at any part, again, what do you get? You again get a circle. Okay. Similarly, any point that you cut here, you get a circle, right? So it has throughout, you see that you are getting a circle if you're cutting the cylinder. That means this has a uniform cross section. Similarly, for a cuboid also, look at a cuboid. For a cuboid, if you look at it from here, okay, what do you get? You get this rectangular face here. You get this rectangular face. Okay. Now what you do is you cut the cuboid from the top. Okay, you just slice it. You get a rectangle somewhat like this here. You get a rectangle like this here. Again, which is this is a rectangle, right? So the cross section is uniform, right? So therefore, this applies to any solid. That for following formulas applies to any solid which has a uniform cross section. Okay. Now let us see what the formula for uniform cross section is. So according to this first formula is that volume, let's say volume and surface area of solids. Let's write it this way. Volumes and surface areas and lateral surface area or curved surface area of four walls, lateral surface areas of solids with uniform cross section. Okay, there are only two formulas for volume and lateral surface areas. The first one is volume of the solid is equal to area of cross section into length. Okay, and the second formula is lateral surface area or area of four walls in case of a cuboid or cube. In case of a cylinder, this is the curved surface area. Okay, lateral surface area is equal to perimeter of cross section. Perimeter of cross section into length. Now let me explain these two formulas first. Let us see. Let us see this cylinder. This cylinder that I have drawn here. Consider the cylinder. I want to find out the volume of the cylinder. Now see this cross-sectional area. This is you have a circular cross section here that I'm getting here. Here this is all are circles, right? Suppose the radius of this cylinder is r. Suppose the radius of this cylinder is r, and the height of this cylinder is h. Then what should be the volume of this cylinder? According to the first formula, if you see volume V, what is the area of the cross section? Area of the cross section, this circle. What is the area of this circle? It is pi r square. So I've got area of the cross section here. Area of the cross section is pi r square. And what is the length? Length is the same as this height of the cylinder, h. So therefore, the volume of the cylinder is pi r square h. Okay. You can apply that to this cuboid also. What should be the volume of this cuboid? If you consider this cuboid, what should be the volume? If I consider this as my L, this as my B, and this as my H, you know that the volume of the cuboid is L into B into H. But where is it coming from? Is it coming from this formula only? Volume of a solid with uniform cross section. Tell me what is the area of this cross section here? This is a cross section is a rectangle. What is the area of this rectangle? Area of this rectangle is length into breadth. So area of the cross section is L into B. What is left? I have to multiply this by the length. Now what is the length here? Length is nothing but the height. So into H. So therefore volume of the cuboid we are getting as LBH, and the volume of the cylinder is pi r square H. Similarly, you can deduce a formulas for lateral surface area also. Let us say in case of a cylinder, okay, lateral surface area, LSA. Lateral surface area in case of a cylinder, you know what it means? It means in case of a cylinder, the lateral surface area here is, except these two shaded circles, whatever area that you are getting. That means only the curved part of the cylinder, only this area. Okay, you see in a tin can, the label that you see on the tin can, the label that you see where the label is put, suppose that Milkmaid can that you see, okay, that Milkmaid can, you have a label outside that Milkmaid can. That label, the area of that label is the same as the curved surface area of the cylinder. Understood? So that part where the label is put, that entire area is called the curved surface area. So this is your cylinder. How to find out the curved surface area of the cylinder? The formula here for curved surface area is perimeter of the cross section. Now, what do you mean by perimeter of the cross section? In case of a cylinder, you have a circular cross section, right? What is the perimeter of this circle? 2 pi r. Let's write 2 pi r. And what is the height? What is the length? The length here is h. So your curved surface area is 2 pi rh. Let us say in case of a cuboid, what should the curved surface area? Curved surface area, perimeter of the cross section. Let us say this rectangular cross section. What is the perimeter of this cross section? Perimeter of this cross section of a rectangle is twice of L plus B, right? This is the perimeter of the cross section into the length. What is the length here? Length is the same as the height. So into H. This is the formula that we know. Area of the four walls, right? That is the lateral surface area. That's what. Having discussed these two formulas, now we proceed to the next problem. That is number 17. If you read problem number 17, there's a little bit there is to understand here in problem number 17. Okay, not 17, sorry, 20. 17 I've already finished. The 20 here is a rectangular plot is 24 meter long. So you have a rectangular plot of land. which is 24 meters in length. Okay, and 20 meters wide, and the breadth is 20 meters. So the length and breadth are given. A cubical pit. What do you mean by a pit? Hole. Okay, you have holes dug in the ground. Okay, so pit means a hole. A cubical pit of edge 4 meter is dug at each of the four corners of the field, and the soil removes is evenly spread over the remaining part of the plot. So now you have, say, a rectangular plot. This is an aerial view of the plot. You know what is an aerial view? You're looking from the top, as if you're looking from a helicopter. Okay, so this is the rectangular plot of land, and what is the area given here? 24 meter. Length is given to be 24 meter. So this length is 24 meters, and the breadth is given to be 20 meters. Let us call this ABCD. Okay, this plot of land ABCD, and a cubical pit is dug at the four corners. At each of the four corners, cubical pit is dug. That means here a cubical pit is dug. This is a cubical pit. At this corner of the land, you see a hole that is dug, a square hole. Okay, a cubical pit. Here also a cubical pit is there. Same here and same here. Okay, so four cubical pits are dug of edge 4 meters. So this clearly, what is the length of this? This is 4 meters. This is also 4 meters, and each of them is 4 meters. Okay, each of these cubical pits is 4 meters. Now what happens? Some soil is was there here. Okay, in all of these, in each of these cubical pits, you had some soil. In each of these cubical pits, you had some soil. Okay, that soil was removed. Okay, and that soil removed from these red shaded cubicle pits, they were put on this piece of land. On this piece, this was on this piece of land. It was put uniformly. Okay, evenly it was put. It was not that hills were formed. It was flat. Okay, these were put and it was made flat so that it becomes even. On this, so from the red shaded part, from the pits, the soil was spread to this blue shaded part. Okay, the question is, by how much does the height get raised? Question is, by what height does a plot get raised? So this plot get raised by a certain height, right? Because if you are putting a soil on a surface, definitely the height of the surface rises. So therefore, by what height does this blue surface rise? That is the question here. Okay, this blue surface, by what height does it rise? So first of all, what is the volume of the what you must realize is that the volume of the soil that is taken out of the four cubical pits, that must be equal to the volume of the soil that is spread, right? Volume of the soil that is taken out of the four cubical pits, that must be equal to volume of the soil that is spread. Okay, so what I do here is, let us first calculate how much soil have I taken out of each pit. So volume of soil taken out of each pit is, each pit is 4 meters and is a cubical, so 4 cube. This is the volume of soil taken out of each pit. And what is the unit here? Meter cube, 4 cube meter cube. Leave it as it is. We'll see later what we can do. Now, how many pits are there? There are 4 cubical pits. So volume of the soil taken out of the 4 cubical pits is volume of the soil taken out of the 4 cubical pits. In from one pit you're taking out 4 cube meter cube, and from therefore from 4 cubical pits, how much are you taking out? 4 into 4 cube. 4 into 4 cube meter cube. This is the volume of the soil that is taken out in total out of the 4 cubical pits. Now this volume of this soil must be equal to volume of the soil that is spread evenly in the blue surface, right? And since the height gets raised by h, let's say the height gets raised by h. Let h be the height by which the plot gets raised. Okay, so by h this plot is getting raised. So how is this plot getting raised? Which part is getting raised? This part, this green part. This form the solid in itself, and this shade, this part, this plus kind of part that I'm shading here. If you see, this plus part is now becomes a solid which has height h. This also, right? This becomes a solid of height h because this has been raised by a height h. And what should be the volume of this solid? This green one, area of cross section into length. What is the area of this cross section of this green shaded part? Area of the rectangle minus area of the 4 rectangular pits, cubical pits. So area of the part of the land except the cubical pits, except the 4 cubical pits, is equal to, what should be the area? Area of the rectangle minus area of the 4 squares, which is, and what is the area of the rectangle? 24 into 20 minus area of the 4 squares on each side. So each square is of what side? 4 centimeters, and there are 4 squares. So there are 4 squares. So there are 4 squares, and what is the area of each of the squares? It is 4 square, right? So this is 24 into 20 minus 4 cube. Let us keep it as it is. We'll see later what we can do with this meter cube, meter square, because we are calculating the area. Now what? This is the area that is the blue shaded area that we have calculated. Okay, this plus part that the outline I have outlined in green. This I have calculated the area, and this area gets raised by what height? This area gets raised by a height of h that I have taken. So therefore, what is the volume of this solid formed by this blue shaded area? Volume of the solid formed by the blue shaded area of height h. What is it? It is equal to area of cross section into length, right? This is solid of uniform cross section. And what is the cross section? The cross section is what you are seeing from the helicopter. This green shaded area that you are seeing, that is the cross section. What is the area of cross section we have found out? Area of cross section we have found out to be 24 into 20 minus 4 cube. This is the area of the cross section. And what is the length? Length is nothing but the height. So this is the this much meter cube. This is the volume. Now see, since the soil is being dug out and is being spread uniformly over this area, that means area of the soil that we have taken out from the pit is how much? This much meter cube. This must be equal to this. So according to a problem, 4 into 4 cube must be equal to 24 into 20 minus 4 cube into h. Now from here we can calculate the value of h. Let's see how to calculate the value of h. So this becomes 4 to the power of 4 is equal to 24 into 20 minus 4. You can multiply and you can do on the normal way also, no problem. This is just a different way of simplification. What you have here is yes, so what you have here is 4 to the power of 4. You have to multiply it. There's no other way out. You have to multiply and then subtract. So 4 to the power of 4 is 256. 256 is equal to 24 into 20 is 480. Okay. And 4 cube is 96 into h. And 480 minus 96 is 384. That means h here is 256 by 384. Okay. So now you can cancel this 256 by 384. Can cancel this with 4. 4, this is 6 times, and this is 4 times, 4 9, and then 4 6 times. Then you can cancel with 8 again, 8 and 12, and then this is 2, this is 3. So this is 2/3 meters. This is the height by which it is raised. You want to convert it into centimeters? 2/3 meters. So let's convert it into centimeters. 2/3 meter means 1 meter is 100 centimeters. 2/3 into 100. That means 200 by 3, which
Sir,
is hmm, 6,
sir, 4 cube is 64.
64. Okay. So, yes, 4 cube is 64. Sixty-four.
416.
480 minus 64.
416.
416 h. Means h is 256 by 416. Now you can cancel this. This will cancel with 4 again. 4 6 and 4 4. 4 104. This will again cancel with 8. 8 8. 8 1 8 3. So 8 by 13 meters. This is the height by which it is raised. I'm going to convert it into centimeters because this is 8 by 13 meters is a small fraction. So we want to convert it into centimeters. So this much centimeter. So this is 800 by 13 centimeters. And 800 by 13 will be your 61.54 centimeters. Okay, approximately. So this is the height by which it is raised. Okay. So long problem. Go through it once again. Okay. And how much time do we have? We have approximately 5 minutes. Time good enough to explain the next problem. Maybe not solve, but explain the next problem. Let us just start and explain.
6153 or 4.
I have approximated it, okay? So that is why it's 0.54. I've rounded it off. You know how to round off? Do you know how to round off? Okay. So next problem here is number 25 that I want to do. Very important problem, number 25. The area of cross section of a pipe is 3.5 centimeters square, and water is flowing out of the pipe at the rate of 40 centimeter per second. You have a pipe here, rectangular pipe. Okay, this is your rectangular pipe, and the area of cross section of this pipe is 3.5 centimeters square. So this is your cross section, or you can consider any circle also inside as your cross section. 3.5 centimeters square. This is the area of your cross section. And water is flowing out of the pipe at the rate of 40 centimeter per second. So you have a column of water. See, this is your column. Okay. This is your column of water. The speed of this water is how much? 40 centimeter per second. That means if this length is 40 centimeter, water has traveled how much distance? 40 centimeter. In how much time it has traveled? It has traveled in 1 second, because the speed of the water is, it is given to be 40 centimeter per second. So if you consider this part, this column of water, this column of water that you considered, okay, now from water is moving from this, from here to here at 40 centimeter per second, per yes, 40 centimeter per second. Yes, that means from here to here the water is traveling in how much time? 40 centimeter. If this length is 40 centimeter, it is traveling this in 1 second only. So this the volume of this this part that I have shaded, this part of the water that I have shaded, this has certain volume, right? And this is the volume of water flowing out of the pipe in how much time? In 1 second. Because water is moving from here to here in 1 second. That means this red shaded part of water, this red shaded part here, okay, this is the volume flowing out of the pipe in how much time? In 1 second. This much volume of water is flowing out in 1 second. And what is the shape of this? The shape of this is a cylinder. This is the cylindrical column of water here. This column of water, this column of water is cylindrical. Yeah, this column of water, this blue column of water is cylindrical. Volume of this blue cylinder must be equal to volume of water that is flowing. And volume of water is flowing, volume, how much volume of water is flowing in 1 second? This volume of whatever this blue cylinder is, that is the volume of water that is flowing out in 1 second. So the question here is, how much water is delivered by the pipe in 1 minute? If this is the volume of water that is flowing out in 1 second, volume of this blue cylinder, this is the volume of water flowing out in 1 second. How much will flow out in 60 seconds? Whatever this volume we find out, multiplied by 60. Okay. So that I'll finish it in the next class. I stop here for today.